Hi everyone. We're going to look at how to use AI for developing scripting tools in Rhinoceros in this tutorial. And for this exercise, I'm going to use Google Copilot, but feel free to use or test any other large language models that are available out there, like ChatGPT, Gemini, or Claude, or any other providers, basically. But for this one, you should be able to log in with your Gmail or UNCC account, and you should have access to the latest models. So I'm going to try to keep this as brief as possible. So we are going to look at elementary cellular automaton, and I'm also going to use AI to help me learn how these things work. Okay, so this is kind of a Wikipedia page where you can find additional information on the topic. But to describe it briefly, it's basically like a grid-based simulation algorithm. And it uses certain neighborhood rules. And it can do one-dimensional, two-dimensional, or three-dimensional cellular automaton using some sort of principles or rules, basically. So before I dive into this, let's ask Microsoft Copilot, like, what is cellular automaton? So what is elementary cellular automaton? Okay. So it's telling that it is basically implementing basic rules to generate complex principles. There are 256 possible rules for elementary cellular automatons. So it's using a 3-cell neighborhood. And the neighborhood is annotated like this. So you can use 1 for active cells, 0 for dead cells, right? So what does this mean? So let's see. It's specifying Rule 30, Rule 90, Rule 110 for potential pattern development. And it's basically giving suggestion for visualizing this using simple rules. So if you look at here, there's basically on the Wikipedia page a simple animation showing us the implementation of Rule 30. So I'm going to zoom in a bit. It's a bit low resolution, but you can see we have like a string of cells. The black ones are active, the white ones are dead. And it's moving through the sequence in triplets, right? So for each triplet, it's finding a corresponding rule set here. So you can see there are 8 different rules. So we have rules for instance, the number 7 shows like when all the cells are active, the next generation will be like a dead cell. In rule number 6, these 2 are active. This is a dead cell, and the result will be dead as well. So in rule 0, for instance, if all of them are dead, the result is dead too. So what the machine is doing, it's basically looking at all these triplets, and it's kind of deciphering what the next generation would be, right? So it's looking at this sequence of rules. So there are a possibility of 256 because we have 8 bits of information here, right? So we can see how the cell configuration can change and rules can change. And there's also a chart showing certain pattern development for certain rules. So you can see there are 256 possibilities, and they all generate different types of structures using these simple binary rules. Okay, so what I'm going to do next is, well, it might be a bit tedious to learn it this way. So I'm going to ask Copilot to help me actually model some of this or visualize some of this in Rhino so that we can actually interact with this this type of algorithm. Okay, so yeah, there are a lot more information and patterned depiction here, but I'm going to move to Copilot and ask it, okay, explain the neighborhood. So it's basically giving me now where left, center, and right are specified. So this was kind of our visualization, right? 0 was kind of a dead cell, 1 was kind of an active cell, and it's looking at all these triplets to assign the next generation. So if you basically come up with a state rule here, and there are 256 possibilities, you will be deciding on the next generation. Okay, so what I'm going to do next is I'm going to ask Copilot. So I had already a prompt written for this, but I wanted to help me develop a Python code for Rhinoceros that can generate elementary cellular automata on an XY plane. I want to simulate the generation on a 32 unit wide, 64 unit length grid, and turn these into XY grid size parameters. Start with random seeds for first layer, give me instructions on how to use it. I want to customize a rule set for generation for it, let's say. Okay, so I basically specified, you have to be very precise with these inputs and give it instructions, and let's see what it does. So now it's basically writing a Python script for me that I can use, and it has these parameters: grid dimensions, x and y count, initial state, rule set, and output. So it's basically telling me to run it in edit Python script command line. So let's see if this would work. So I'm going to move this around here and bring up a Rhino. So it's saying open Rhino, type in edit Python script. All right, so this prompted a toolbar, and we can just copy paste it here. And it says you can customize X count, Y count, and the rule set. So let's see what happens when we run it. I got an error. Let's see, this is basically line 10. So let's paste this in. So it's saying we cannot do a CII character, so let's remove that. So if you get any type of errors, you can basically give it back to the code and it will clean it up. All right, so that was actually pretty quick. So now it is simulating in the XY plane, like the way we specified it, the code as points, basically. And we can start with points. So it's going to do 32 by 64 like I specified. And this should be, let's see which model it implemented. So it implemented rule 30. So let's check if it's rule 30 actually. So I'm just going to go back here and find out rule 30. So it's essentially doing these sorts of triangulations, but it started with random seeds, right? So it started with random points here, which is very interesting. So let's see if we can customize this a bit. So what I'm going to do is select these points and move it aside because our simulation would run here anyway. And now we can implement a different type of rule. So let's see if we can find something a bit more interesting. So I'm going to look into, let's say, to the chart and pick something else. Let's see what we can do. 101 seems very interesting. So let's see. Ask Copilot, what is the rule set for 110? Rule 110. So it's giving me this line, which I can replace here. And let's run this again. Let's see what's happening. Rule set is not defined. Oh, well, it's supposed to say rule set here because that's being used. So I'm just going to copy this portion here and just paste it. Okay, now it's printing rule 110, essentially. All right, this might take a while, but you can see my triangles, or the triangulation is kind of rotated in this version. So it was, the hypotenuse was facing the x-axis, but now it's facing y-axis here, right? So we can basically plot different variations like this. Now we can of course run it in Rhino as code, but what if we want to build this as a tool in Grasshopper? So I'm just going to ask it to help me build this as like a script that we can run in Grasshopper. So can you give me instructions on how to implement this in Grasshopper? All right, so we're going to build a Grasshopper definition that simulates 1D cellular automaton with custom rule set. So it says use a Python component. So let's open Grasshopper now. So we can double click here and type in Python. So you can use either one of these. And with inputs, we need to put in X count, and it has to be an integer. So you have to right click here, go to type hints and specify integer. We need a random seed, which is Boolean. So go to type hints, do it Boolean, and output is going to be A. So that's fine. Let me see, it's actually giving me a lot of complex stuff. Build the automaton, first rule, second rule. Can you give me a single Python code that I can use? All right, so it's basically now giving me separate inputs, X count, Y count. So let's add that as well. Y count. We need a cell size. We need the rule set and random seed. Perfect. So this is the whole code. So I'm just going to copy it. You can double click into Python component and you can just paste your code here. This will be our output. And it's basically going to generate the rule set automatically inside of it. So if I press this now, it won't work. It will give me an error because we don't have anything plugged in here yet. So it's giving me the same instructions, paste the code above and connect inputs and run. All right, so let's do 32 for X count, Y count, let's do 64. Cell size, let's do 1. Rule set 110. Random seed, let's do a Boolean toggle and false. So open it up. It's still giving me an error. So it's basically saying rules type of, this is basically float. So let's see if this needs to be an integer. Rule set needs to be a Boolean toggle or a gene pool. Can I use a number for rule set? All right, so single integer. Yes, we want to supply from 0 to 255. So, okay, so it can convert it apparently. So it gave me an updated code. So let's copy this one and replace the existing code. Press play. Rule number is not defined. So rule number now has to be an integer. So we need to do a rule number. So change this parameter input. So I'll just need to specify it as a rule number. Type int needs to be an integer. Y count needs to be an integer as well. So right click here, this needs to be an integer. And all right, so this is an error that maybe we need help with. So it says this module doesn't have a .3D component. So I can just copy and paste this here and ask it basically like, what are we supposed to do with this error? So it's saying, well, the Rhino script syntax doesn't have this method. So instead, it basically fixed it with something Grasshopper compatible. So we can just copy this version of the code and press play. Now it seems like it's working, and basically that's it now, right? So this was our Python script, and this is from Grasshopper. So I can actually ask it to further modify this, but let's see if it's working the way we anticipated. So we can change the grid size here, so it's extending it diagonally. This is controlling the vertical dimension. This is controlling the rules set basically. Okay, so this will have to go from 255 to 0. So these will be all the possible rules with this type of component. And if I do a random seed, if I make this true, it will basically populate a bunch of random points here and simulate this, which is perfect. Okay, so we got the points as an output. We can actually use these points to add more geometry to them, or we can simply go back to Copilot and ask it to give us more outputs. So for instance, can you give square surfaces as outputs? All right, so now it's modifying the code. Let's see, it didn't change probably the inputs. The inputs seem to be the same. So all I can do is like make a copy of this. What you can also do is like you can make a copy of your existing code. You can disable the old version so it doesn't run. And you can copy the new version that you got and paste it here and run it. Perfect. So now we got basically everything visualized as a grid, right? So we built this with Copilot. So let's see how it works. So I'm going to change the rule number. Beautiful. So it's actually running all of the 256 possibilities of Cellular Automata, and we can control the vertical dimension and the horizontal dimension as well. And if I disable the random seed, it basically starts with a single seed point at the center here. So this is very nice. So let's actually add a bit more functionality to this. So I'm going to disable this. Now let's say I want to be able to input the seeds as a list, as a collection or a list of points, as a collection of points. All right, so seed points is now added as a list of points. So the randomization is probably taken out. So we can just make another copy here, rename this as seed points. And it has to be a list input. So if you right click here, go to list access and type in should be point3D. All right, so let's see. In Rhino, draw points on the XY plane where you want the seed cells. In Grasshopper, reference these points using the point parameter. Okay, should I place the points? Should I place the points on x-axis? All right, so they should have y as 0, z as 0, x coordinates. Okay. Okay, you should add to the grid size. Perfect. So let's do a point here. I'm going to copy this, paste it here, run it, but it's not running because it's disabled. So let's enable it. Now it's giving an error. So what is there? Okay, we don't have any seed points yet. So let's place in some seed points. So I'm just going to place a bunch of points here, select them, right click here and set multiple points. And that's basically it. So if I now move these points around, you can see that controls the generation. So I can actually change the rule set and those will become the seeds for generation. All right, so essentially this could get very, very complex, right? So you can imagine developing multiple rules here and also changing rules as the generation progresses, basically. So I just want to show you another example I have developed. So I'm just going to move these around. So this will also be given, provided to you, but basically, let me see, this one, okay, it doesn't have, so let's disconnect this. All right, so this is actually running not on the XY plane, but on the XZ plane, and it's just giving me these sorts of blocks, right? Initially, let me see, so we don't need this one. We can also input points to this. So let's actually place some points along this plane. Set multiple points and then place these in. All right, so it's basically giving us these sorts of stacked outputs. I can just disable the preview so that we can just see the blocks. Now what's nice about this one is it basically turns the geometry into 3 dimensions, but you can also do multiple layers using this system, right? So you can control the amount of layers in the Z direction, but also in the Y direction. So you can stack different generated values. And one more thing I added to this one is you can actually implement, let's say you built this or something similar using AI. You can use the last layer points as an output, like a separate output. And you can start a new rule set from those, from that layer. So this basically does that. So I'm going to disable this version, enable this version. So what this does is it uses, let's say, our points as input. So I'm just going to do, all right, select these, right click here, set multiple points. All right, so it's basically starting with rule set 30, and it's going to basically stop at some layer, right? Which is going to be this layer 30. And then if I enable this, the next generation can take a different type of rule set, which is rule 203, or we can implement something else here as well. Let's actually change this to 30. Let me see. So 30 goes diagonally. Let's find something with a bit more pattern. Oh, this is just controlling the width. All right, so let's keep it at 30. Rule set should be, let's say, 30. All right. So I want to keep the widths the same. So I'll just keep this 30 as well. But the rule set, let's change it to be something else, right? So we can see the stacking changing actually. And you can add to this. For instance, let's say this one runs only 16 steps, and then we make a copy of this here, and then plug this in here. So let's change it into a different rule set like that. And we can also plug this in here, right? So that's actually quite interesting. So now I have basically rule 30 running 30 levels. Then it switches to rule 172 running 16 steps. And then we have rule 190 running 16 more steps, right? So the whole generative process can be stacked and layered and broken down into different types of rule sets and layers. Okay, this one also has a wrap function, which basically makes sure that the algorithm doesn't run to an end. It basically comes back to the beginning. So the right side affects the left side, basically. So if I make this true, it will change the patterns a bit. But you can also play around with different types of parameters here, right? So that it should be pretty straightforward. So we have a rule set, width and step. Step basically controls the vertical dimension. Cell size controls the size of these blocks. And at the end, I'm just visualizing a box at the location of the point. Okay, so these are some options you can investigate, but it will be very nice if you can also start thinking about different types of rules with the AI. So you can essentially chat, and if you have errors, you can paste the errors. It will help you fix the issues. And you can use the tools, the scripts to run directly inside Rhino, or you can basically build your own Python scripts in Grasshopper and generate outputs. Oh, and once you want to, let's say, generate these, all you have to have is bake. So you just right click here and do bake, and that will basically output that variation, right? So now we have basically three-dimensional volumes instead of points. But you can always start with points and turn them into geometries. All right, so I hope this helps to kind of give you a sense of like how Cellular Automata works and play around with the codes that are provided. But use AI as like learning tool as well as scripting tool so that you can build custom workflows for generating these sorts of structures. Okay, and I hope you have fun with this. And in the next video I'll show you how you can do more complex three-dimensional implementation using AI.